Isosceles and equilateral triangles. Our objectives are to prove theorems about isosceles and equilateral triangles, as well as apply properties of isosceles and equilateral triangles. Recall that an isosceles triangle has at least two congruent sides. The congruent sides are called the legs. The vertex angle is the angle formed by those legs, and the side opposite the vertex angle is called the base, making the base angles the two angles that have that base as a side. So looking at this figure might help. So angle 3 is our vertex angle. These are our two congruent sides for the isosceles triangle. Our base angles would be 1 and 2 because our base is across from 3. The isosceles triangle theorem. If two sides of a triangle are congruent, then the angles opposite their sides are congruent as well. So if you have an isosceles triangle, the two sides are congruent, then that means the two base angles are going to be congruent. The converse of the isosceles triangle theorem states that if you have two base angles that are congruent, then those two sides or legs will be congruent. Let's look at the proof for the isosceles triangle theorem. So we have AB is congruent to AC, and we're trying to prove that the base angles are congruent. So we're going to draw in an auxiliary line, so AX, the midpoint of BC, because we know that every segment has a unique midpoint. Now we can utilize our AX. So we have BX is going to be congruent to CX because of the definition of midpoint. Now we can use our other given. So we have AB is congruent to AC. And then we have AX is congruent to AX for the reflexive property of congruence. Now that you have enough information, you have one side, two sides, you have three sides. So BX, CX, AX, and AX, and then because it's an isosceles triangle, you know you've got AB and AC. Well, therefore, your two smaller triangles are congruent, so we can use SSS, or side, side, side. And because we have two triangles that are congruent, all of the other pieces are going to be congruent as well. So that means we can state that angle B and C are going to have to be congruent because of the CPCTC. Let's look at an astronomy application. The distance from Earth to nearby stars can be measured using the parallax method, which requires observing the positions of a star 6 months apart. If the distance LM to a star in July is 4.0 times 10 to the 13th kilometers, explain why the distance from L to K to the star in January is the same. Assume the distance from Earth to the Sun doesn't change. We know it does, but for the sake of this problem, we're going to assume it doesn't. Okay, so we need to figure out what the other base angle is here, because we're trying to state that this side is in fact congruent to this one, but we don't know that yet. So we have that this angle right here is 90.4 degrees, and we have a line. So we know that line KP makes 180 degrees, so we can do 180 minus 90.4, which gives us 89.6. And since base angles are congruent, using the converse of the isosceles triangle theorem, we can state that ML and LK must be congruent. So therefore, LK is also 4.0 times 10 to the 13th kilometers. Let's find angle measures. So find each angle measure. So if the measure of angle C is what we're looking for, and we know that the measure of angle A is 38, and we have an isosceles triangle, we can still utilize the fact that we know that a triangle is 180 degrees. So we can start by saying 180 minus 38, and that gives 142, and that means these two angles together are 142 degrees. Well, each of them have to be the same exact measure, so just do 142 and take half of that, which ends up being 71 degrees. So the measure of angle C is 71 degrees. You could also have done 38 plus x equals 180 and solved for x. Alright, so we have another isosceles triangle here, and we know that our base angles must be congruent. So we have x plus 30 equals 2x. So subtract x from both sides, and we have 30 equals 30 equals x. And now we can substitute that in to find the measure of angle S. So we have 2 times 30, which is 60 degrees. Using the idea of an isosceles triangle folds us right into our equilateral and equiangular triangle. If a triangle is equilateral, then it is equiangular. Same with going the reverse. If a triangle is equiangular, then it is equilateral. So equilateral, equiangular, they're both triangles, they will be each other. So let's try putting that property to use, or those corollaries to use. So this one is an equilateral triangle, so you know it is equiangular. So therefore, angle C must equal 60. So we have 3x plus 15 equals 60. We can subtract 15 from both sides, and we'd have 45. And then we can divide both sides by 3. 15. Okay, so x is 15. In this problem over here, we want to find the value of t. And since it is an equiangular triangle, we know it is also an equilateral triangle. So we have 4t minus 8 equals 2t plus 1. So we're going to add 8 to both sides and subtract 2t from both sides. So now we have 2t equals 9. So t equals 4.5. And that ends our lesson on isosceles and equilateral triangles.